Hey, how's it going? Today we're going to be doing Meerkat from Hack the Box, which is another Sherlocks machine. This time it's an easy rated and it requires us to parse through some JSON log files from a intruder detection system, which is flagged on a number of interesting alerts. And we also need to parse through some PCAP files to determine whether or not a fast-growing company has been compromised and the extent of the compromise. So without further ado, let's jump into it. Okay, so looking at the scenario, we've got a fast-growing startup and we are a new security provider for them. They've told us that their administrators aren't the most security-aware people, and they'd like us to work out whether or not they've been compromised by looking at some network traffic capture and some log data that they've provided. So we can see the two files here, the PCAP, and there's a JSON log file. And the first thing I want to look at is what we've got inside of the JSON file. So I'm going to open it up in a Linux shell because I want to use a Linux binary called JQ, which I think is short for JSON query, to parse through this JSON file and see what we can discover from it. So to start with, I want to find out what's in the file and how it's structured. And so I'll just do a cat and I'm going to pipe it to JQ dot. The dot just puts you to the root of the JSON object. And then I'll just do a head and show the first 50 rows. So we can see that we've got an array with a number of objects, and each object has a whole bunch of information. We can see it's an event, and there's a whole bunch of information about each of these alerts that we can parse through. The first thing I want to look at is these signatures. So it'd be good to get a list of what signatures have been flagged within this log file. But to do that, we're going to need to just clear the screen. We're going to need to use some more JQ tricks to pass through things nicely. So the JQ syntax is a little unusual, but I'll try my best to explain it as I go through. So I want to start by creating an array. So I'll open up the array and I want to parse through from the root of the JSON object, and I want to go through each item within the array. And so the period puts us at the root. This will parse through each element within the array. And then we can use these pipes within the quotation marks. And we can select, what was it called? Alert and signature. So we want to get, we can call it alert, and this will be dot alert. So from the root we're getting alert, and then we want the signature. Actually, I think we can just do like that. So if we just print what we have, oh sorry, close the quotes, and we have an error because I haven't closed out the array. So what we should have created is an array with each object in the array being an alert with the alert signature, and that's what we've got. Okay, cool. So the next thing we want to do is sort through and just get unique alerts. We can do that with the sort and unique binaries in Linux, and we can see that works. But we can also do that within JQ. So if I go inside the quotes, I can actually pipe that to a sort function that JQ has and a unique function within JQ. So now we've got them all listed out, but it'd be nice to have this a little neater, and we really just want a list of the alert signatures. So we can add to the end a start from the root of this object we've just created. We want to parse through each object within that array, and we want to print out the alert. And here we go. We now have a curated list of all of the alerts that have been flagged within this log file. There's a whole bunch of interesting stuff here and worrying stuff. I can see there's possible attack with a etc parsewd file, poor reputation IP addresses, a specific CVE referenced here with an attempt to exploit Bonitasoft with an authorization bypass. So if we do a quick Google search on this CVE, authorization bypass, so we can see it's a critical CVE. I believe Rhino Labs were the people to discover this vulnerability, and we can read through their write-up here. They've also created a proof of concept which you can have a look through and read through the proof of concept exploit script and work out how it all works. But from this point we can answer the first couple of questions. So if I jump across, confirm the name of the application running on the server, I can assume that this is Bonitasoft just based on the CVE. And additionally, task 3, does the vulnerability have a CVE assigned? If so, which one? And we can answer that one. And not sure what else we can answer, but I am interested. The other thing that stuck out to me is the Python requests as a user agent. This would indicate to me some sort of scripting or potentially malicious activity, which is obviously why it's been flagged. But I'll just get a little bit more information about this and try and get a feel for how many requests have been made, what IP addresses were involved, etc. Just to get a bit of a feel for what might have been happening here. So I'll start the query the same way as previously, but this time what I would like to do is a select statement where I will select just the alert signature. I'll put a question mark. That will basically mean it will error or handle errors better if it's a null or a blank value. Within these brackets I can also use a pipe, and I can pass this to a strings query and pass that to a string to test for, which in this case is going to be Python, and also make it case insensitive. So let's just see if that works. Okay, it looks like it's printing out the correct data. So we've now got we should have an array, yep, an array of JSON objects, each of which are alerts on these Python requests. What I might do is just have a look at how many source IPs and destination IPs there are, and how many times this has happened. In order to do that, I will use the array we've just created, and I can just do a length to see the total number of objects within the array, and we can see it's 134. I'll save this for the time being because this might come in handy later on. And we can also create a query just to show the source or destination IP. I'll start with the destination IP, and I will just do a once again, I want to start at the root, loop through every object within the array. Inside there I want to see the destination IP. Let's see, maybe if I close off the array there. Yep, that's better. And from here we can sort and unique -c, and we can see there's just one destination IP address and the number of times that has been hit. I'm going to save this as well. And I also want to see the source IP. And we can see that there are two. One that's only done 18 and then 116 requests from this IP address. So I'll save this as well in case we need to cross-reference it as we're looking through the PCAP file. Okay, so going back to the list of alerts, beyond the Python requests, we can also see a VNC scan or potential VNC scan, so that's a network scanner, and suspicious traffic inbound. And we can also see some default logon attempts, which are distinct from the successful default user logon attempt. We can also have a look at this to see how many attempts there were and how many successes there were. So instead of Python here, we can say default user as the keyword to search for, and I'll go destination IP. Okay, but this is going to give all of the attempts, so we can see all of the successful and unsuccessful attempts here. I'll save this as well in case we need to refer to it. And if we want to see just the unsuccessful ones, we can just give a better query here. So we'll search for this whole string. Oh, that's not going to work because they've both got it. Let's search for this whole string. So we'll do the other way. We'll get the successful attempts. Okay, so we can see 4 successful default logons to 2 different source IP addresses. So we'll keep that in mind as we move on to look at the network traffic analysis. So let's open up the PCAP in Wireshark. Let's see if I can make this a little bigger. Yep, here we go. That should be a little easier to read. So the first thing I want to do is follow on from what I was looking at with the Python user agent requests, because that's obviously pretty suspicious activity. So I know that the alert said something about Python user agents, and I should be able to filter the HTTP traffic based on user agent. So to do that in Wireshark, I can do http.useragent. Yep. Instead of strict comparison, I'll just use a contains and give it the string Python. And we can see 134 packets displayed, which matches what we got out of the log data. And we should now be able to see a lot more detail about exactly what was parsed. So if we step through, we can see just a large range of username and password combinations. Every second one seems to be install, which might be one of the default passwords. But each of these usernames looks to have a unique password against it, so it doesn't look like a password spraying type attack, but possibly credential stuffing, where credentials for fellow employees have been captured in some sort of previous breach, and those are being used on different services around the domain to try and gain unauthorized access. So if I go back to the questions that we have, question 2 states, we believe that the attacker may have used a subset of the brute forcing attack category. What is the name of the attack carried out? And I believe that is credential stuffing. If we look at task 4, there's a question about what string was appended to the API URL to bypass the authorization filter by the attacker's exploit. We can answer these questions by having a look at the proof of concept and reading about how the exploit works, just based on the CVE that was flagged from the logs. But I'll also show how we can do that within Wireshark. So if we want to search by the URI, so for example, if we're trying to find API URIs, we'll want to have a look at what we want to search on. And it looks like we want to search on the HTTP request URI. So if you're ever worried about how to search within Wireshark, you can always just look through the information down here, and it'll tell you what the object's called within Wireshark, and you can use that to build your queries up here. So in this case, we want URIs that contain API dot request URI contains API, and we can see all of these requests to various API endpoints. So we can see at the start there's a page upload, and it seems the URI contains a semicolon with some sort of string, so some sort of unusual string appended to the URI here. We then have some remote code execution attempts. We can see a CMD, who am I? And the second time this exploit gets run, we can see a cat on Etsy parse WD, and then it gets run a third time, and there's a wget which is run on this URL, and a fourth time, and there is a bash command which is executing the file which was downloaded with the wget command up here. So it looks like a malicious actor performed some sort of bypass to achieve remote code execution. They've done a who am I to try and test the execution in the first instance. They've then dumped the Etsy parse WD file, which will give them information about active users on the box. And for example, that might then tell them other files they want to read off the box, for example, SSH keys. And then they download a file, and then they execute that file. So I'm also very interested to have a look at what this file is. If we can copy this, copy value. We'll store this one for later. Firstly, we should be able to answer one of the questions with this. Which string was appended to the API URL to bypass the authorization filter by the attacker's exploit? And we can see it's this I18N string here. And so we'll grab that as well. And I believe that is the string. While we're here, we can also, if any, which text sharing site did the attacker utilize? We can answer that at this point. It's the pastes.io, but we'll have a look at that in a second in more detail. And so that's .io is the answer there. And we can open that up to see what file was downloaded to the box. And it's a simple bash script. It's doing a curl on another file and writing it to this user's SSH authorized keys, and then restarting the SSH service. So basically they're dropping authorized keys to be able to log in with their own SSH keys. So if we have a look at this file, I would expect that's going to be a public key, which it is. So with this information, we can answer a couple more questions. Firstly, please provide the file name of the public key used by the attacker to gain persistence on our host. That is going to be this file name here. and then confirm the file that was modified by the attacker to gain persistence. That's going to be the authorized keys file, and I believe it requires the full path. And finally, can you confirm the MITRE technique ID of this type of persistence mechanism? I don't know about you guys, but I definitely don't know my MITRE technique IDs off the top of my head. So just a quick Google search should be able to help on this one. Technique, dropping SSH keys. Maybe I'll say for persistence. So if I go to this one, which is about account manipulation, SSH authorized keys, we can see there's a bunch of sub techniques in here. Bit of a giveaway that I've already clicked on this link, but the answer is indeed technique 1098, sub technique 004. We just need to circle back and answer these last two questions in the middle here, which are about how many combinations of usernames and passwords were used and which username and password combination was successful. So these were slightly trickier to answer. The first way I attempted to answer it was using the log files, where I knew that there were 134 attempts just based on the number of flags with the Python requests. And I also knew that there were, 63 attempts which were just with the default user. So I knew 63 of these were at least repeats. So I thought it was 134 less the 62 duplicate defaults, and that gave me 72. So the next way that I went about trying to answer this was to go to Wireshark and filter for logins with the default credentials. Okay, so back in Wireshark, what I'll do this time, instead of searching for the Python requests, so what I originally searched for was user agent contains Python, and we could see that while there were a bunch to the logon service, there was also Python requests made to the RCE and bypass. So these 134 packets aren't all related to the credential stuffing attack. And I also don't know whether there was other attempts in the login service that weren't run through Python. So what I really want to do is filter on the URI, which has the logon service. In order to do that, I want to set the request URI path. Oh, there's one I prepared earlier. The request URI contains logon service. And so we can see all of the hits on the logon service, of which there are now 118 rather than 134. So the next thing I want to do is filter out the duplicates. And I know just from looking at it that there are a lot of duplicates with install, which are the default credentials. So to filter these out, we can also just apply it as a filter, the value. And we can see it applies the filter for us and gives us 59 attempts with the default username and password, which matches with the 59 that we got from the logs. And so my first guess then was that we have 118 less 59. And so there were 59 unique attempts, but again, that wasn't the correct answer. So I had to look through for any other duplicate usernames and password. And to do that, what I wanted to do was change this one from a does include to a doesn't include. So if I put that in brackets and put a bang at the start, and then I can add the query, which is request URI contains login service. So we're now searching for hits on the login service URI, which didn't contain the install value. We do get 59 hits as we expected, but now we need to work out whether there were other duplicate usernames and passwords. So there's probably a more sophisticated way to do this, but the way I helped filter through this was to sort it by length. And I wanted to have a look at all of the requests with identical lengths, because the only thing that should really change is the size of the post data. So if the post data is the same, it's probably worth checking out to see if there are any duplicates. No duplicates there. 125. No duplicates there yet, except for Seb Broom. So we can see that there's one duplicate there, and we can have a look at how many times that was repeated. So 1, 2, 3, 4, 5, 4, which gives us so less the 3 Seb Brooms, which gives us 56, and 56 is the correct answer. The final question is which username and password combination was successful. So to answer this, I want to see what the server is sending back based on the negative responses, and then see if I can follow the conversations and find where there's been a successful logon. So the first thing I'll do is follow the HTTP stream, and we can see there's a post and the response from the server is 401. And if I jump in, I can look at the stream. I could try and sort by the response code or something along those lines. But what I'm interested in is the traffic between these two IP addresses, because it seems that the attacker is using the same IP address. So I'll just do a conversation filter based on IPv4. And I just want to look at the HTTP traffic, and it's in sequence of time. So we can see that the credential stuffing starts here, and we can follow it down. We can see all the 401s. And we get to the bottom here where there's a 204 response. And if we have a look at the, it was the Seb Broom and government credentials. So the correct answer here is going to be Seb Broom. Seb Broom, and the password of government. So that'll about do it for this box. It was a nice easy one, but some interesting questions which helped to test your familiarity with Wireshark querying, but also parsing through JSON data, which is really useful in all sorts of forensic analysis. So it's a good one to become familiar with. Anyways, leave a comment below if you have any comments or questions. Otherwise, I look forward to seeing you in the next one.